Okay, so today we're going to be looking at asynchronous programming. What is it and why is it useful? So, the best way to do this is probably to look at an example. So, this is a website I built. It is a game where you're supposed to begin with a starting topic, and by looking at its Wikipedia article and following the links within that article, you're supposed to arrive at this target topic within 10 links. So, a big chunk of this page has already been loaded and the code has already been run for it, but there is also some code that doesn't run until later. So the big part, of course, is the chunk of code that actually requests this article and then displays it. So anytime that there is a chunk of code that's meant to run now and then a chunk of code that's meant to run later, and there's a gap in between, that is when we're going to be using asynchronous programming. It's basically how do we handle the fact that there's this gap between the code that runs now and the code that's meant to run later. You can think of this as kind of like a conveyor belt. So imagine a conveyor belt, and on that conveyor belt there are these boxes that get loaded. And as the boxes reach the end of the conveyor belt, they can be handled. So like this box, let's say, is ready to be taken care of, so we take care of it. And then these boxes continue down the conveyor belt, and maybe another box is loaded onto the conveyor belt. Well, as these boxes are handled, eventually maybe there's a box that has a note attached that says, hey, this box is waiting on something. It's not quite ready to be handled. And then we have a decision to make. Do we stop the entire conveyor belt? Do we hit the stop button here and not do anything else until this box is ready to be handled and then move on? Or do we simply set this box to the side and continue to take care of boxes until that box is ready to be handled? And once that box has what it needs, it can be loaded back onto the conveyor belt and that one can be handled as well. Well, those two options there are the same options you have in programming. So in programming, you can think of the way the environment runs chunks of code as the conveyor belt. So this oftentimes is called the event loop. So this would be like a event loop. Oops. Event loop. And the boxes, they're like chunks of code that get added to the event loop. And as they reach the front of the event loop actually runs that code. And most often the chunks of code is actually a function. Well, not every function can be run when it reaches that part of the event loop. Every once in a while there is a function that is waiting on something else. And that would be the type of, or the chunk of code that we would need to institute asynchronous coding for. We would need to set it to the side until it's ready to be handled. So some examples where you might find this in your code would be timers. So if you were to set a timer and say, hey, don't run this chunk of code until this timer expires, we would of course want to be able to do other things while that timer is running, and that would be an example of when to use asynchronous code. Buttons, there's a chunk of code that is attached to a button that is not meant to run until that button is clicked by the user. Well, of course, we're going to want to be doing other things while we're waiting for the user to click that button, so we would use asynchronous coding there. Requests to outside resources, like on the web page that I built where I request a Wikipedia article from the Wikipedia API. We would like to be able to do other things while we're waiting for that Wikipedia article, and that would be a situation where we wanted to institute asynchronous coding as well. So let's actually look at the web page I built again, and you're going to see how I instituted asynchronous programming in this web page. So when I click this button, you're going to see a spinner that pops up, and that spinner only appears after I've made the request for the Wikipedia article. Now, if this was done synchronously, like if I were to hit the stop button on the conveyor belt once I make that request, I wouldn't be able to do anything else, including add a spinner right here to show that it's waiting on something. The program would just freeze. But this web page is built asynchronously, so when I click this button, you're going to see a spinner appear here. So right now, we're waiting for the article. And once that article arrives, this spinner is going to go away and it's going to get displayed. Now, I could also do this synchronously. So if I were to do it synchronously, again, I click that button and the whole program doesn't do anything else until that article is ready to be displayed. And actually, I modified this same web page so that it does do that. So Now when I click this button, there's going to be no spinner. And in fact, it'll look like the program has froze because the program's not going to allow anything else to happen until that article is ready to be displayed, because it's basically like hitting the stop button on the conveyor belt. Nothing else gets run. So let's see that. So I click the start digging button, and now you can see even my cursor is locked in that pointer position, and then the article gets displayed. So let's look at it one more time. So once I click the start digging button, you're going to see that my cursor locks up. There's no spinner. There's no way for the user to know whether the program's completely frozen or whether it's just waiting on something. So I click the button, and again, it looks as if it's froze until this article gets popped up. And that's not the way we should structure our programs usually. So how is this done in JavaScript? So it's done using two methods, either callbacks or promises. And we're not going to be looking at either in this video. We'll save those for future videos, just because I kind of want to take a general overview of what asynchronous programming is. But we will be looking at both in future videos. So if you found this video helpful, be sure to like and subscribe, and happy coding.